Differential and integral operations 7 show that if B vector is curl of a vector A, then for any closed surface S, closed surface integral d sigma dot B is equal to 0. Now let's recall Gauss theorem. The volume integral d tau divergence of a vector B is the closed surface integral that is at the boundary of this volume d sigma dot product with B. So this is Gauss theorem. All right. So if B is equal to curl A, vector B can be written as the curl of another vector A. Then let's look at the divergence of B. This would be divergence of curl A, obviously. And using the subscript summation notation, the del operator is del xi in EI hat direction. And we're going to write curl A in EJ hat direction. So we will have epsilon jkl EJ hat del xk applied to AL. So del AL del xk using the subscript summation notation. And this part is Kronecker delta ij, which means I will be set equal to j. So this will give us epsilon ikl del xi. Epsilon is a number, so it doesn't have to be here. You can take it up front. And we have del al del xk. All right. And now let's call k as I and I as k. So we're going to switch the two indices so that this will become epsilon kil del xk, because I has been renamed as k, del al del xi, because k has been renamed as I. And ikl to kil, so kil so we go from k to I to l. This is the positive direction here. If I go to ikl, that's the negative direction. So this would be equal to let's copy it here. Minus epsilon ikl, and I have del xk del al del xi. Now the order of the derivative doesn't matter, so I can also write this as minus epsilon ikl del xi del al del xk. Okay, so order of the derivative derivative is not important. So I can do that. Now I compare this with what I have here. Epsilon ikl del del xi del al del xk minus epsilon ikl, the same thing. Now this is telling us that so if B is equal to curl A, divergence of B must be equal to 0. All right? Then we can conclude the closed surface integral d sigma dot B must be equal to 0 due to Gauss theorem. Okay, so we're given that a vector B can be written as the curl of another vector. Then for any closed surface S, the closed surface integral d sigma dot B must be 0. We have to show this. The closed surface integral d sigma dot B is for the closed volume integral, the integral d tau divergence of B. This is Gauss theorem. If B is equal to curl A, then divergence of the curl is equal to 0 will imply that this integral is 0. Divergence of a curl is indeed 0. We have shown this before in problem 4, actually. Divergence of the curl is 0, but we can redo it here anyway. So we go to subscript summation notation. Del del xi ei hat is this operator. Del del x j ej hat is this operator. But so here we're doing del del xi ei hat dot product with the j component of curl A. J component of curl A, or curl A in ej hat direction. Ej hat epsilon jkl, we have del del xk al. So this is how I write the curl. And ei hat dot ej hat is Kronecker delta ij, I and j must be equal. So I have epsilon ikl del del xi del al del xk. So I call ki and ik. So I switch the k and I, and then I change the positions of k and I, and odd number of cyclings will give me, permutations will give me a minus sign here. And then I can change the order of the derivatives and show that this is equal to itself with the minus sign, which means it is 0. So divergence of B must be 0. If divergence of B is 0, this integral is 0 according to Gauss theorem.